11.4, Congruence Transformations. Now, congruent figures are figures that have the same shape and the same size. So what this means in terms of transformations is that they can be mapped onto one another using transformations. And we will look at that a little bit more here to come. But for right now, take a look at our example over here. Congruent figures, same shape, same size. So these are all quadrilaterals and they're all the same size quadrilaterals, so these are congruent figures. Now, not congruent, different sizes or shapes. These are all triangles, but they're not the same exact triangle, so they're not congruent. If we have congruent figures, they are literally the same exact size and the same exact shape, just in a different location. Example 1, identifying congruent figures. Identify any congruent figures in the coordinate plane. So the first thing I'm looking at is I'm going to identify this rectangle, and I'm going to wonder if it's congruent to this rectangle. So first of all, they are the same shape. They're both rectangles. And second of all, it would be, are they the same size? Well, this is 1 by 2, and this is 1 by 2. So they're the same size. So we can say that IHGJ is congruent. That is the symbol for congruent. It's an equal sign with a squiggly on it, to QPNR. Same shape, same size. They are both 1 by 2. Now I'm going to go find some triangles, and I'm going to look at this triangle versus this triangle. Well, they look the same to me, except one's kind of pointing to the left and one's kind of pointing to the right, but they are the same exact shape. So the question is, are they the same size? Well, this side is 2 units long, this side is 2 units long, this side is 2 units long, this side is 2 units long. So yes, same shape, same size. So I'm going to say triangle LKM is congruent to triangle TSU. And again, same shape, same size. Let's go look at our last set, and I'm going to look at these triangles up here. They look like they're the same size. I know that this side is by 3, this side is by 3. If I use the distance formula, I could get a little more specific, but from E to F, I've kind of got 2 diagonal boxes, and from B to C, I've kind of got 2 diagonal boxes, and then from E to D, I've got like 2 diagonal boxes, but a bigger one and a smaller one. And then from B to A, I've got 2 diagonal boxes and kind of a bigger one to a smaller one. So these are in fact the same size. So I can say triangle DFE is congruent to triangle ACB. And same reason, they are the same shape and the same size. Now, is it true that this triangle EDF is congruent to this triangle MLK? Because they are both triangles. And the answer there is no, because yes, they're both triangles, but they're not the same size.